Now we are going to derive shape functions for four-noded quadrilateral element in natural coordinate system. Okay, that is, in this video we learn how to derive shape function for four-noded quadrilateral element. Four-noded quadrilateral element. Okay, in a natural coordinate system. Okay, in natural coordinate system. Okay, I have done videos on these shape functions. Already I have done some videos on this shape function. Without this shape function, we cannot solve some problems. Okay, we cannot calculate nodal displacements. Okay, that's why we derive shape function for each and every element, like bar element, truss element, CST element. Okay, I have already derived. There is a link in a description. Please visit our channel. Okay, this is in this video we learn how to derive shape function for the four noded quadratic element in natural coordinate system. Okay, so without this shape function we cannot solve some problems in our FEM, that is in our finite element method. Okay, so this is very important subject point of view as well as subject point of view as well as exam point of view. This derivation is very essential in our MTech, in our BTech or in our PhD. Okay, this is very important subject point of view and as well as exam point of view. So now we are going to derive shape function for quadratic element. We know that four-noded quadratic element. What is the four-noded quadratic element? Here I have a graph quadratic element. Okay, this is y-axis. Okay, this is x-axis. Okay, it consists of three-noded, four-noded element like this. Okay, it has consist of four-noded. Okay, this is node 1, this is node 2, 3 and 4. These are the four nodes. Okay, every node has 2 degrees of freedom. That is, every node 2 displacement occurs at every node. Okay, we call it as in x direction u, in y direction v, in x direction u2, in y direction v2, in x direction u3, in y direction v3, in x direction u4, in y direction v4. Okay, these are the displacements occurred in a quadrilateral element. There are 4 displacements. Every node has 2 displacement because it has a 2 degree of freedom system. Every node has 2 degrees. Okay, 2 displacements. Now, that is, this is point 1. That is, it consists of x1, y1, and this is point 2. That means x2, y2 coordinates, and this is x3, y3, and this is x4 and y2. These are the points in a quadrilateral. Now, consider, we know that I will draw here. We know very well about the four coordinates because without no, we know that four coordinates. That is, it consists of this quadrilateral element consists of 4 nodes. That's why I am taking a 4 coordinates triangular element. Okay, this is the 4-noded triangular, that is rectangular element. This is node 1, node 2, node 3 and node 4. Okay, this is the point -1 and -1. Okay, This is the point. It indicates in 4 coordinates. This is the point -1 and -1. This is point 1 comma -1. This point consists of in 4 first coordinate. That's why I will write 1 comma 1, and this point is consist of second coordinate. That's why I will write -1 and 1. That is unit displacement is there in each quantity. Each element, but the position is different. That's why I am right here. X distance is 1 and y distance is 1. That is, it is in this point is in first coordinate. That's why I write first x displacement is 1, y displacement 1. That means unit displacement. Okay, and the second element. So third element is like that, and fourth element it is minus x and -1 distance and positive 1 distance. That is x value is -1 and y value is 1, and first node it is in third coordinate. That's why I write -1 -1 means 1 displacement, unit displacements of the node. Okay, this is the position for the entire quadrilateral element. Now we know that displacements of that is the relation between the displacement and shape function. We know that. So okay, I will write here u is entire interior displacement. So write here each and everything. u1 and u2, u3 and u4 are the nodal displacement. u1, u2, sorry, u1 v1, u2 v2, u3 v3. That means u1, u2, u3, u4 are nodal displacements along x direction. Okay, now write that is write v direction. That is v1, v2, v3 and v4 are the nodal displacements along y direction. You know that. Okay, already I have told you that v1 and u1, u2, u3 and u4 are the nodal displacements. That is nodes displacement along x direction. I have already told you. But y direction displacements are v1, v2, v3, v4. v4 are the nodal displacements along y direction. I have already told you that each node has two displacements. Okay, one is x direction and another one y direction. That's why I am writing here. So each and everything regarding that 4-noded quadrilateral element. This is the 4-noded quadrilateral element. Okay. Now n1 and n2 and 3 are n1, n2, n3, n4 are shape functions for 4-noded quadrilateral element. Okay, I have already told you that there are 4 nodes here. So because of this reason we will get 4 shape functions. Okay, this is n1, n2, n3 and 4 are the shape functions for 4-noded quadrilateral element. Okay, now we know that relation between the shape functions and displacements. We know that. So entire interior displacement along x direction is equal to along, and that is total displacements, interior displacement along x direction. We can write this is n1 u1 plus n2 u2 plus n3 u3 plus n4 u4. Okay, this relation is this relation is very essential to find out nodal displacement. This is the relation between the shape function and nodal displacement. Okay, we can find nodal displacement, that is nodes displacement or element displacement, by using shape function. Without this shape function we cannot calculate nodal displacements. Okay, that's why I write here. Okay, we know that similarly v is equal to n1 v1 plus n2 v2 plus n3 v3 plus n4 v4. This is equation number 1, this is equation number 2. These two equations are very essential to find out nodal displacements or shape functions. Okay, now we know that u1, and that is we know that polynomial function, we know that polynomial functions, that is u is equal to a1 plus a2j plus a3 eta. Okay, a2 a3 eta plus a4 j eta. Okay, this is equation number 3. Now we know that similarly we know that a1 plus a2 j, that is a1 not a1 a5, there are already a5 a6 j plus a7 eta plus a8 j eta. It is equation number 4. Okay, now find out these a1 a2 a3 a4 are polynomial functions. Okay, these a1 a2 a3 are polynomial function. This is the j and eta and j is the natural coordinate systems coefficients. Okay, these j and eta natural coordinate system coefficients. Okay, now find out a1 a2 a3 a4 for that is for the purpose of shape functions. Okay, I am taking only third equation. So okay, so from equation 3. Okay, so substitute all these values in equation 3. Substitute all these equations. Okay, that now at u is equal to u1 j and eta is equal to node 1 is equal to -1 and -1. That is substitute these values in equation number 3. Okay, we can get u1. So substitute. So u1 is equal to u means u1 and a1 plus a2 j value is -1 plus a3 eta value is also -1 plus a4 j value -1 into -1. Okay, that is j value is -1, eta value is also -1. Substitute this u is equal to u1. So substitute these boundary conditions. This is the boundary conditions. Okay, boundary conditions in our polynomial function. Okay, u means u1. I am already write. So a plus is equal to a1 constant polynomial function constant and a2 into, so j value is -1 plus a3 into eta value is also -1 plus a3. So after solving, after simplification, we will get u1 is equal to a1 minus a2 minus 1 into a2 minus a2 minus a3 into -1 minus a3 plus a4. This is the equation number 5. Okay, this is the equation number 5. So Okay, now substitute boundary condition 2 at node 2. This is node at node 1. Right here at node 1. Okay, this is a node at node 2. So u is equal to u2 and j and eta will be 1 comma minus 1. So substitute all these boundary condition in equation number 3. We will get u means here u2 is equal to a1 plus a2 here j means 1. Okay, 1 plus a3 into eta value is minus 1 plus a4 into j into 1 j into eta, that is 1 into minus 1. Okay, so now simplify this. So u2 is equal to a1 plus a2 minus a3 a1 a4 into 1 minus 1, that is minus a4. This is the equation number 6. Okay, now at node 3 u is equal to u3 and j and comma eta will be 1 comma 1. Now substitute all those values in equation number 3. We will get u is equal to u3. It is equal to a1 plus a2. J value is 1 plus a3 eta value is also 1 here eta plus a4 j into eta, that is 1 into 1. So now simplify this equation. a3 is equal to a1 plus a2 plus a3 plus a4. This is the equation number 7. Now at node 4, u is equal to u4 and j comma eta will be minus 1. Okay, minus 1. So substitute this value here. Okay, in this third equation, u is equal to u4 is equal to a1 plus a2 x value is j value is minus 1 plus a3 into 1 plus a4 into minus 1. So minus 1 into 1. Now simplify this equation. So a1 plus minus a2 plus a3 minus a4. This is the equation number 8. So we got 4 equations, 5, 6, 7 and 8, and 4 unknowns, that is a1, a2, a3, a4 are the unknowns here. Okay, a1 plus a2 plus a3 plus a4 are the unknowns. So 4 equations, 4 unknowns, so we can easily solve this equation. We will get, after solving these equations, we will get a1, a2, a3 and a4. Okay, now simplify from equation number 5, and that is add equation 5 and 6. Add here, right? Add equation 5 plus 6. Add equation 5 comma 6 comma 6, that is 5 plus 6. Okay, add it. Now after adding this, that is 5th equation and 6th equation. Now write it here. So u1 it is equal to a1 minus a2 minus a3 plus a4. Okay, here 6th equation, here u2 is equal to a1 plus a2 minus a3 minus a. This is the adding. After adding, so after adding a1 that is a2 cancel, and here a4 also cancel. So remaining is, so have you, after adding these two equations, we will get u1 plus u2 is equal to 2a1 minus 2a. This is the finally we got. Have you okay, I will show you. Okay, so this is the equation we got. u1 plus u2 is equal to 2a1 minus 2a. Okay, now add 7 and 8. So this is equation number, this is the equation number 9. So this is equation number 9. Now add 7 and 8. So add equation 7 and 8. We got 7 plus 8. Okay, that is 7 plus 8. Now from 7th equation is u3 is equal to a1 plus a2 plus a3 plus a4. This is equation number 7, and the eighth equation is, so u4 is equal to a1 minus a2 plus a3 minus a4. After subtracting, after adding, a2 cancel and a4 also cancel. Now we will get u3 plus u4 it is equal to 2a1 plus 2a. This is the equation number 10. From equation 9 and 10. So 9 and 10, right here. 9th equation is u1 plus u2 it is equal to 2a1 minus 2a2. Next, here u3, that is the 10th equation, u3 plus u4 it is equal to 2a1 plus 2a. So this is the a3 value. Okay, so this is equation number 9, and this is the equation 10. Okay, now add these two equations. Okay, after adding these two, 2a3 cancel. So finally we got a1 plus u1 plus u2 plus u3 plus u4 is equal to 4a1. a1 means a1 is equal to 1 by 4 of u1 plus u2 plus u3 plus u4. Okay. Now this is the polynomial coefficient a1. Okay, that is equal to a1 is equal to 1 by 4 into u1 plus u2 plus u3 plus u4. This, okay, this is the value of a1. Now our subtract from equation 9 and 10. Subtract these two equations. Okay, that is u1 plus u2, it is equal to 2a1 minus 2a3 u3 plus u4, same equation, it is equal to 2a1 plus 2a3. So now subtract these two equations. Okay, here minus, here also minus, here also minus, here also minus. Here these two a1 is cancelled. 2a1 minus 2a1 is cancelled. We got here. I will show you. So some other side. So it has a space. So now adding these two equations, we will get, so u1 plus u2 minus u3 minus u4, it is equal to minus 4a3. Okay, this is the final equation we got, that is a3 equation. Okay, now simplify this equation. Okay, now simplify this equation. Okay. We will get, now simplify this equation. Now simplify this equation. So we know that u1 plus u2, so here is minus 4. So multiply with my entire equation with the minus, we will get minus u1 plus minus u2 plus u3 plus u4 into 1 by 4. This 4 is, so send it down other side, that is we will get a3. So right here a3 is equal to 1 by 4th of a3 is equal to 1 by 4th of minus u1 minus u2 plus u3 plus u4. This is the value of u3. Okay. Now take 5 and 6 equation. Now take 5 and 6 equation. Okay. Two a3. So we got now take 5 and 6 equation, 5 and 6 equation, that is subtract, that is 5 minus 6. Okay, so subtract from 5 50 equation to 60 equation. 50 equation is here, right here. So u1 is equal to a1 minus a2 minus a3 plus a4. This is the 50 equation. And 60 equation is u2, it is equal to a1 plus a2 minus a3 minus a4. This is equation number fifth, and this is equation number sixth. Okay, so please check it. U1 it is equal to A1 minus A2 minus A3 plus A4, and U2 equation is sixth equation is U2 is equal to A1 plus A2 minus A3 minus A2. This is the two equations we got. Okay, now subtract minus 1 plus. Okay, after subtracting U1 U2 is equal to this A1 cancel, and this A3 cancels. So remaining is 2A2 plus 2A4. Okay, plus A4 plus A4. That is 2A4, and here minus A2 that is 2A2. That is U1 minus U2 is equal to minus 2A2 plus 2A4. This is the equation number 11. Okay, now so take 7 and 8 equation. Now take 7 and 8 equation, that is subtract 7 minus 8. Okay, now write it. So 7th equation is U3 is equal to A1 plus A2 plus A3 plus A4. This is the 7th equation. Okay, 8th equation is U4 is equal to A1 minus A2 plus A3 minus A4. Okay, this is the 7th equation. 7th equation is, so U3 is equal to A1 plus A2 plus A3 plus A4, and U4 that is 8th equation is here A1 minus A2 plus A3 plus minus A. This is the equation number 8. So subtract these two equations. We will get, so this is minus plus plus. Okay, minus, this is minus plus. Okay, so after doing this, so A3 cancel, and A1 is also cancelled. So remaining is, so U3 minus U4 is equal to A2 plus 2A4. Okay, U3 minus U4 it is equal to 2A2 plus 2A4. Okay, so this is equation number 12. Now from equation 11 and 12. So from equation number 11 and 12. So here this is also positive plus 8. Okay, from equation number 11 and 12. Okay, 11 and 12. So right here U1 minus U2 is equal to 2A2 minus 2A2 plus 2A4. Here 12th equation U3 minus U4 is equal to 2A2 plus 2A4. So add these two equations. So 2A2 cancel. So remaining is U1 minus U2 plus U3 minus U4 is equal to 4A4. Okay, 4A4. We want A4, so it is equal to 1/4 of U1 minus U2 plus U3 minus 2. Okay, this is the value of polynomial value of A4. A1, A2, A3 are polynomial coefficients. Okay, That's why I am finding these values. So now here added. So subtract these two from equation. Here I added 11 plus 12. That is, here I am added. Here I am subtracted from equation number 11 and 12. That is 11 minus 12. Okay. You know that u1 minus u2 is equal to minus 2a2 plus 2a4. So here writing. So u3 minus u4 is equal to 2a2 plus 2a4. Now subtract. That is, this is minus, this is plus, and this is minus, this is also minus. Okay. Here minus, here plus, here minus. That is, I am subtracting. Okay. Here also minus. So a to a2 cancel. So remaining is, so u1 minus u2 minus u3 plus u4, it is equal to not a2 into, so f4 cancel, f4 and f2 cancel. Okay. Here it equals 2a2 and this one is 2a2, but here this value is minus. So minus 2a2 minus 4a2. Okay. Because here 2a2, here also 2a2. So total is minus 4a2. So a2 value is multiplied with minus 1 by 4, 1 by 4, multiplied with minus. Okay, minus u1 plus u2 plus u3 minus u4. Okay. This is the polynomial function 2. Okay, we got a1, a2, a3 and a4. Substitute this a1, a2, a3 in equation number 1. We will get nodal displacements. Okay, that is, we know that u is equal to u1, sorry, u it is equal to n1 u1 plus n2 u2 plus n3 u3 plus n4 u4. Okay, sorry. You know that. So u is equal to a1 plus a2j plus a3 eta plus a4 j and eta. So I will extend here. Okay, please wait. Substitute all these polynomial coefficients, that is a1, a2, a3 and a4. Okay, already I have calculated there. Okay, please substitute all those values, you will get the u. Okay, that is interior displacements. Now substitute. So u is equal to a1, we know that. So here we got a1 value, that is 1 by 4 of u1 plus u2 plus u3 plus u4. Okay. Now plus a2 value here we got. So 1 by 4 of minus u1 plus u2 plus u3. So I will write. Okay. Here 1 by 4 of minus u1 plus u2 plus u3 minus u2 minus u. Okay. Next. into j. This, that is a2 value is 1 by 4 into minus u1 plus u2 plus u3 minus u4. Okay, into j is there. J. Okay, next plus a3 value. A3 value already I have find it, that is 1 by 4 of minus u1 minus u2 plus u3 plus u4 into eta. Okay, eta I have written it here. Okay, plus a4 here already I find here 1 by 4 of, so u1 minus u2 plus u3 minus u4 into j and a. Okay, so we got like this. Okay, now simplify this entire equation. Okay, we will get final solution. Okay, now u is equal to, you know that u is equal to, I am taking 1 by 4, so commonly I am taking here. Next 1 by 4 is there, 1 by 4 is also there, so 1 by 4 is common for all the elements. Okay, I am taking outside and u1 here. Okay, u1 value is here is 1 here 1, and here is minus j, here is minus eta, here minus plus j and eta. So we got u1 value. Okay, just I am taking u1 values here, u1 here, u1 here, u1 here. Okay, so just I am taking outside u1, and 1 by 4 is common for all elements, that's why 1 by 4 write it in common. Okay, next 1 by 4 is also common, so now take outside u2. Okay, here u2 is there, u2 is also here, and u2 here, and u2 here. Now write. So here u2 value is 1. So after taking outside u2, so value is 1, and here plus j, here minus eta, here minus j eta. This is the value of u2. Now plus 1 by 4. Now take outside u3. Okay, here u3 is 1, and here u3 is j plus j. Here u3 is plus eta. Here u3 is plus j and eta. Okay, we got like this. Plus I will write here 1 by 4 of, take outside u4. Here u4 value is 1. Here u4 value is minus j. 1 minus j, and here u4 value is eta plus here u4 value is minus j eta. This is the equation. Finally we got u is equal to, u in terms of n1 u1, n2 u2, n3 u3. Okay, so we can simplify this equation also. So u is equal to 1 by 4 of 1 minus j into 1 minus j. Okay, plus into u1 plus 1 by 4 of, this can be written as 1 plus j into, so 1 minus eta. This can be written as like this. This can be written as like this. Okay, plus 1 by 4 of this can be written as 1 plus j into 1 minus 1 plus eta, plus this can be written as 1 minus 4 into 1 minus 4 into 1 minus j into 1 minus j into 1 plus eta. Okay, just I am writing in bracket forms. It can be written as 1 minus j into 1 minus eta, 1 minus j into 1 minus eta. Okay, these quantities can be written as 1 plus j into 1 minus eta. Okay, this quantity can be written in 1 plus j into 1 minus eta. Okay, next this can be written as 1 minus j into 1 plus eta. So this is just like u is equal to n1 u1 plus n2 u2 plus n3 u3 plus n4 u4. Okay, this is entire equation like this. Okay. So now n1 means this is the n1, this is the n2. Sorry, here u2 plus okay, n1 is equal to 1 by 4 of 1 minus j into 1 minus eta. Okay, n2 is equal to I will write here only 1 by 4 into 1 plus j into 1 minus eta. Okay, n3 it is equal to 1 by 4 1 plus j into 1 plus eta. n4 means 1 by 4 into 1 minus j into 1 plus eta. So these are the shape functions we got. Okay, we know that. So this can be written as, so these shape functions we have to derive. Okay, so this shape function is very essential to find out nodal displacements for a 4-noded quadrilateral element. Okay, so we know that. So similarly we can get v is equal to n1 v1 plus n2 v2 plus n3 v3 plus n4. We can substitute all those values here. We can get v1 v2 v3. So in matrix form you can write in matrix form u and v it is equal to n1 0 n2 0 n3 0 n4 0. It is equal to 0 n1 0 n2 0 n3 0 n4. It is equal into u1 v1 u2 v2 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 u3 v3 u4 v4. Okay, this is the final equation we got. Okay, this is the relation between the shape function, that is nodal displacements, and shape function and the nodal displacement, anterior displacement. U displacement is equal to n into 2, just like this. Okay, here n is shape functions and q is displacements. Okay, this is the process of deriving shape functions. These shape functions are very essential to find out nodal displacements, node displacement, interior displacements. Okay, if you got nodal displacement, we can easily calculate stresses and strains. okay, in that particular element. Okay, this is the process. Okay, I will show you entire equations.